Hello. Hello, students. Hello. Hello.
Yes, ma'am.
Uh, can you hear me?
Yes, ma'am.
Okay. Good afternoon, all of you.
Good afternoon, ma'am.
Good afternoon.
Okay.
Good afternoon, ma'am.
Today we are welcome to New LGIT Institute of Engineering and Technology for the mathematics lecture. Today we are going to start the basic maths lecture. Students, ninth lecture we are going to teach basic. Please mute your audio. Please mute your audio. Unmute if I ask you any question. Otherwise, mute your audio. Okay? Okay. Dear students, today we are going to discuss some basic maths topic. First 9 lecture, we are going to discuss the basic maths because which is very important to you, for the engineering mathematics. You already aware about all that topic, but we just look a short note, and then after we are going to teach engineering mathematics. The topics are indices, surds, logarithm, differentiation, integration, binomial theorem, trigonometry, etc. Okay. Uh, First, in this lecture, I am going to teach you very basic topic, that is indices, surds, and logarithm. Can anyone tell me what is indices? Now unmute and answer me. Option. Okay. Okay. Students, can anyone tell me what is indices?
Ma'am, it can show that how many times the number has been multiplied by some number or something like that.
Okay. Anyone else? Anyone else?
It is the power of the number. Like how many times the number has multiplied it by itself, has been multiplied by itself.
Okay. See, the term indices refer to the power to which a number is raised. You both are right? Okay. Now, 64, which we can represent as 2 into 2 into 2 6 times. So it is 2 raised to 6. Like now here 2 is base and 6 is power. So 64 is equal to base 2 raised to power 6. Now the law on indices. Uh, First law is multiplication. X raised to a into x raised to b equal to x raised to a plus b. There is one example, that is x raised to 5 into x square. Dear students, the base is same, multiplication is there. So there is the addition of the power, that is x raised to 5 plus 2 equal to x raised to 7. Can anyone tell me what is the x raised to 5 into x raised to minus 2? x raised to 5
It's
into
x raised to 3.
X raised to
X raised to
3.
5
X raised
into
to
1
3.
upon
Raised
x
to
raised
7.
X cube.
X raised to 3.
X raised to
yes,
3.
X
very
raised to
good
3.
because we represent it as x raised to 5 minus 2 that is x raised to 3, right? Now for the division x raised to a upon x raised to b that is x raised to a minus b. Okay, so x raised to 5 upon x raised to 2. So x raised to 5 upon x raised to 5 minus 2 that is x cube. Now tell me x raised to 6 divide by x raised to minus 4. Now, what is the answer?
10. It's x
X
raised
raised
to
to
10.
10.
10.
10.
Because
X raised to 10.
here
raised to
minus,
10.
yes,
10.
yes,
raised to
good.
10.
Yes,
X raised
because
to 10.
here minus minus is plus, minus minus is plus, so x raised to 10, right? Now, the third rule is base raised to 2 powers. X raised to a raised to b equal to x raised to a into b. That is x raised to 2 raised to 3. That is x raised to 2 into 3 is equal to x raised to 6. Now, tell me what is x raised to 2 raised to 3. What is this?
X raised to 9.
X raised to
X raised to 6.
6.
X raised to 6.
X raised to 6.
X
Are
raised to
you
6.
sure?
X to the power.
6.
Yes,
Dear
ma'am.
Yeah.
students,
Yes,
no.
ma'am.
Hell yeah.
That is not x
X
raised
raised
to.
to 8. 8
X
X
raised
raised
to
to 8.
8.
Okay,
No,
okay.
X raised
it's
to 8.
gonna be
Yes, yes.
x raised to 6,
Now,
ma'am. 8, 8, 8, 8,
please stop. I
6.
gave you the answer. If we have x raised to 2 raised to 3 and there is a bracket, then it is x raised to 2 to 3, that is x raised to 6, right? But if we have x raised to 2 raised to 3, it means
X raised to 8.
x raised to 2 raised to 3 that is x raised to 8. So dear students, x raised to 2 raised to 3 if there is bracket then that is x raised to 6. But if x raised to 2 raised to 3 and there is no any bracket then that is x raised to 8. So both are different. Okay? Any doubt? Any doubt?
Oh,
Okay.
no.
Okay.
No, ma'am.
Okay, thank you. Now, the multiple bases to the same power. If we have multiple base, there are some, different base, x, y, and the power is same, then we apply the same power on the all base. That is x, y raised to 3. It means x raised to 3 into y raised to 3. Similarly, we can apply for the numbers 2 into 5 raised to 2. That is 2 raised to 2 into 5 raised to 2. We can also write as 2 into 5, that is 10. 10 square, 100. Here 2 square is 4, 5 square is 25. So both are same. Now the next rule is multiple bases to the same power for the division. This is for the multiplication. This is for the division. So the same rule apply here. X upon y raised to 3. It means x cube into x raised to 3 upon y raised to 3. Right? Now the negative power x raised to minus a, that is 1 upon x raised to a. So if we have x square upon x raised to 5, it means x raised to 2 minus 5, that is x raised to minus 3. It means we have the negative power, and this negative power we can represent as 1 upon x cube, which is also known as reciprocal or inverse of x. And the last rule of indices, that is the power 1 and 0. If we have power 0, base is any one, then that is any non-zero number, then the answer is 1. And the power is 1, base is any non-zero number, then the answer is the number itself. Dear students, can you give me the answer for the infinite power? If your base is any non-zero number and your power is infinite, then what is the answer?
0.
0.
Zero.
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 X raised to infinity is 0.
It will be not defined.
Undefined.
ma'am.
It is not
Finite.
defined.
It is indeterminate.
Finite.
Dear students, it depends on the value of the x. If your x, it means your base is between 0 to 1, then it is the different, and if it is greater than 1, then it is the different. I will ask you in the next lecture. Please recall and give me the answer tomorrow. Okay. I give you two questions. What is the answer of x raised to infinity? And next, what is the answer of x raised to minus infinity? Right? I will ask you in the tomorrow's lecture. Right? Now, tell me, what is surd? You can. Yes?
A sort is an expression that maybe includes square root, cube root, or maybe other roots. If it
Okay.
is right.
Okay. See, square root of 4. Is it surd?
No, ma'am.
Yes.
Square root of
No.
4.
Yes.
Is it surd?
Yes.
No, ma'am.
No,
Yes.
ma'am. No.
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 Why no?
No.
Because
It can be
it's
reduced to simpler form.
Because it is reduced in the simpler form, or we can say it give a perfect answer. Square root of 4 is 2. So it is a perfect number. So
yes.
see,
It
a
is not a
surd,
surd.
okay, a surd is a square root which can be reduced to a rational number. Surd is what? Surd is a square root which cannot be reduced to a rational number. Dear students, here square root of 4, square root 25, square root of 4 is 2. Square root of 25 is 5. So these
Five.
expressions are called roots, but this expression can be written in numerical in exact quantity, right? Or we can say the perfect number. So these are not surds, but square root of 2, that is 1.41 up to etc. Root 5, 2.2360. Such numbers are called irrational number, and it is often convenient to leave them in the form of root 2 are called surds. Right? See, for the easy understanding, if any square root, cube root, fourth root, fifth root, if it has not a perfect answer, or we can say that it cannot be expressed in the exact quantity, then that number is known as surds. If square root, cube root, fourth root, or any nth root, we can express in the exact quantity, then that is not a surd. Now, the law on surds. Root x into root x. If we have two same surds and if we want to multiply, then that we have the answer x itself. So root 2 into root 2, 2. Root 3 into root 3 is 3, like that. But if we have root 2 into root 3, but one number is root 2, other is root 3. If both are not same, then we can return as under root of 2 into 3, that is root x into y, root 6. Very good. See here, root 5 into root 7, that is root 35. Similarly, for the division, under root of x upon y, that is root x upon root y. So, under root 100 upon root 25, that is root 100 upon 25, that is root 4, equal to root equal to 2. Square root of 4 is square root of 2. Can anyone tell me what is the answer of square root of 18? Just simplify square root of 18, 1 8.
Three root two.
Square root of 18.
3 root 2.
3 root
3
3
root
root
2.
2.
3
3
root
root
2.
2.
Okay, right. And what about square root of 28?
2 root 7.
2 root 7.
Perfect.
2 root 7.
Very good, very good. 2 root 7. Right. Now, surds as indices. Nth root of x we can represent as x raised to 1 by n. We can also write cube root of x. That is what? X raised to 1/3.
1 by 3.
Yes, fifth root of x, that is x raised to 1 by 5. So
1
if
by 5.
we have multiple base x, y and have the same power 1 half, then we can represent x raised to 1 half into y raised to 1 half and in the form of square root. Similarly, for xy raised to 1 by 5, then we represent x raised to 1 by 5 into y raised to 1 by 5, which becomes fifth root of xy. That is the fifth root of x and the fifth root of y. Right? Similarly, this is for the multiplication and the similarly for the division. Here, x upon y raised to 1 by 5. That is x raised to 1 by 5 upon y raised to 1 by 5. It means the fifth root of x upon y. So, fifth root of x and the fifth root of y. Square root of 32, which is 16 into 2. So, square root of 16 into root 2, that is 4 root 2. Now, the common mistakes which will be done by the student, that is x plus y whole raised to a, then student can write the x raised to a plus y raised to a. Dear students, we can write this if we have the multiplication or division symbol is there. If we have x into y raised to a, then we can write x raised to a into y raised to a. And if we have x divided by y whole raised to a, then also we can write x raised to a divided by y raised to a. But for the addition and the subtraction, this rule is not applicable. So please remember x plus y whole raised to a, which is not equal to x raised to a plus y raised to a. Right? So square root of x plus y, which is not equal to square root of x plus y, square root of x plus square root of y. So we can say that square root of 9, which is not equal to square root of 4 plus root 5. Similarly, x plus y the whole square, which is not equal to x square plus y square. We can say 5 square, which is not equal to 3 square plus 2 square. Right? Uh, I will ask you some question. Please give me the answer. What is the answer of square root of 28 into square root of 18? Square root of 28 into square root of 18.
It's 12.
See, what is the
6
answer
root
of,
14.
see, what is the answer
It's
of,
42. It's
6 root
42.
14.
6
42.
root 14.
14.
6 root
6 root
42.
just a
42
minute,
is
Root
just,
14.
42.
6 root 14.
oh, okay,
42.
please stop answering, please stop answering. Square root of 28, that is square root of,
46.
just a minute,
7 root.
just a minute. See, this is 4 into 7. This is 9 into 2. 2 root 7. This is 3 root 2.
6 root 14.
6,
6 root 14.
6 root 14.
14, right?
6 root 14.
So this is the answer,
Root
6
14.
root 14, right? Now, rationalizing the denominator. A fraction that contains a radical in its denominator can be written as an equivalent fraction which are rational denominator. Dear students, if you have given 7 upon root 2, if you have given 7 upon, see, 7 upon root 2. Then for the simplification, you have to multiply by your denominator because your denominator is irrational number. So for the simplification, you have multiply and divide by the same number root 2 upon root 2. So that is 7 root 2. Here root 2 is into root 2 is 2. So your answer is 7 root 2 upon 2. Please give me the answer of 3 upon root 5.
15 by 5.
3 root 5
3 root
upon
5 by 5.
3
Root 5 upon 5.
3 root 5
Root 5 upon 5.
3 root 5 upon
Very
3
5.
root 5
by
upon 5.
5.
Okay, thank you. Thank you. Now, if your question is 3 upon 7 plus root 5, dear students, in your denominator, there is a mixed rational number, right? Irrational number. So here 7 plus root 5, we can say that if your denominator is more than one term, then for the simplification, you have to take a conjugate of the denominator. Okay, so 2, 7 minus root 5 in the denominator 7 plus root 5 into 7 minus root 5. Here a plus b into a minus b. What is your a plus b into a minus b? That is a square minus b square. Your a square, 7 square is 49. B is root 5 square is 5. So 49 minus 5, that is 44. And 2 upon 44, that is 22. So 7 minus root 5, which is 7 minus root 5 upon 22. Now, tell me the answer of 4 upon 4 upon 6 plus root 3. 4 upon 6 plus root 3.
4 bracket 6 minus root 3 upon 33.
4 by 33 into 6 into
24
minus
minus
root
root
3.
3. 24 minus 4 root 3 upon 33.
See, 4, 6
24 minus 4.
24 minus 4 root 3
yes.
upon
Please, there is no need to open the bracket. 4, 6 minus root 3 upon 33.
33.
Right?
33.
3. Yeah.
Okay, okay.
Yeah.
Now, what about the square root of 8 plus 10 upon root 2? Square root of
Under
8.
root of 6. Yeah, 4 plus 10 root 2 by
4
2.
plus 10 root 2 by 2.
So here,
8.
root 8 plus 10
2
4
plus 5 root 2.
into root 2
2 plus 5
upon
root 2.
Divide
2
by 2.
7.
root.
4 plus
Plus
10
5
root
root 2.
Please stop answering.
2 plus 5 root 2.
Stop answering, otherwise I will mute all of you. Root 8 into root 2, that is root 16 plus 10 root 2 upon 2. Root 16 is 4. 4 by 2 is 2 plus 5 root 2. Dear students, if you have asked, convert your term root 8 plus 10 upon root 2 into the form of p plus q root 2. Into the form of p plus q root 2. Then your p is 2, right? And your q is 5.
5.
Right. So this is your answer. If you have asked, convert root 8 plus 10 upon root 2 into the form of p plus q root 2. Now, logarithm. A logarithm is the exponent to which the base must be raised to produce a given number. It means how many 2 need to be multiplied to get 8? How many 2? 3 times 2. Answer is 2 into 2 into 2, that is 8. So 2 raised to 3 equal to 8. If we want to write this term into the form of logarithm, our base is 2. So log, here base is 2. Log base 2, 8 equal to 3. For this, what is our base? Our base is 10. So
10.
log base 10, 100 equal to 2. Log base 3, 81 equal to 4. Vice versa, log 2, 8 equal to 3. If we convert into the form of indices, then 2 raised to 3 equal to 8. Here 10 raised to 2 equal to 100. 3 raised to 4 equal to 81. So the another definition of the logarithm is a raised to x equal to y, then x is defined as logarithm of y to the base of a. Now the laws on logarithm. Students, first law of logarithm is log a plus log ax plus log ay is equal to log axy. This rule we apply if and only if the base is same. Here the base is a in the both term. Okay, if we have given log ax plus log by, then we cannot write log abxy. If the base is same, then we can convert our addition into the multiplication. Similarly, for the subtraction, we convert into the division. The third rule is log a x to the power n. Here our power is n. So we can represent n log a x. Log a nth root of x. So log a x nth root we can represent in the form of 1 by n. So as per the rule of third, our power is 1 by n. So we represent 1 upon n log a x. Dear students, please mute your audio. Unmute if and only if I ask any question and if you want to answer in any question. Otherwise, mute your audio. Dear students, log log 1. For any base, log 1 is 0. Log infinity is infinity if your base is greater than 1. Log 0 is minus infinity. Again, your base is greater than 1. Now, the next, both last, log ex. This e is known as the natural logarithm. Then we can represent in the ln x. And if your base is 10, then that is the logarithm with the base 10, then we represent in the form of log. Please remember, this ln we represent only for the natural logarithm, right? Now let's take a view on the some small example. Simplify log a4 plus log a2. Here the base are same, log a. Addition is there. So log 4 into 2, so log 8. Okay, now for the subtraction, log a base a4 minus log base a2, that is log base a 4 upon 2, that is 4 by 2 is 2. For the third rule, simplify log base a 4 raised to 2. Here 2 is the power, so we represent this term as 2 log base a 4. Now, if log base 3x is equal to 5, find x. Can anyone? Can anyone?
3 raised to 5.
Yes, very good. Very good. X is equal to 3 raised to 5. And what is 3 raised to 5?
243.
Perfect. 240.
243.
Perfect, perfect. Okay. So, give me the answer of square root of square root of 40 for k root 10. Square root of 40 k root 10. Find k.
2 root 10.
2.
2
2
root
is 2.
Two.
A is 2.
Good.
A is 2.
Very good. Now log base 2 x is equal to 7. Now what is your x?
49.
49.
Is to 7.
Your x is not 49.
2 raised to
2
7.
Yes.
128.
Yes.
128.
Perfect.
2
Your
raised to
base
7.
is 2. raised to 7, so 128. Very good. Please give me the answer of 2 root 12 plus 9 root 3.
Thirteen root 3.
13 root 3.
13.
13 root
13 root 3.
13 root 3.
13 root
Okay. Now, give me the answer of root 6 into root 15. Root 6 into root 15.
3 root 10.
3 root 10.
Perfect. 3 root 10.
10.
Now, what is the answer of root 20 into root 5 upon root 2?
5.
5 root 2.
5 root 2.
only 5.
5 root
Only
2.
5.
5 root 2.
It's 5 root 2.
5
5
root
root
2.
2.
Perfect. 5 root 2. Okay.
2.
Now, 27 upon 8 raised to 2 by 3.
9 by 4.
9 by 4.
9 by 4.
See, 3 raised to 3
9 by
upon 2
Ma'am,
raised
3
to
by
3.
4. 3 by 4.
Just a minute.
9
3
by
raised to
4.
3 upon 2 raised to 3. Whole raised to 3. 2 by 3.
9 by 4.
3 are cut.
9 by 4.
3 square upon 2 square. 9 by.
It will be 9 by
9 by
4.
4. 9 by 4.
9 by 4.
Okay. Now, 2 raised to 4 raised to 4.
2 raised to
2
16.
raised to 16.
256.
Raised
2
to
raised to
16.
16.
Okay. 3 plus 5 into 3 minus root 5. 3 plus root 5, 3 minus root 5.
4.
4.
4. 4. 4.
Okay.
4.
Can anyone tell me square root of 1 by 4 is surd or not?
It's not
1 by
surd.
2. 1 by 2.
Yes,
No.
1 by
1
2.
by 2.
No.
1 by 2.
1 by 2 is not.
Not surd.
Not surd.
It is not surd because it
Not
is
surd.
It is not surd. Not surd.
Yes.
Not surd.
It is give a exact answer. So it is not a surd. Now what about the cube root of 11? It is surd or not?
Short.
It's a
Surd.
surd.
It is
Surd.
surd.
It's a
Yes,
surd.
third.
Yes, perfect. Now log base 3 7x plus 3 is equal to log base 3 5x plus 9. See, dear students, equal sign is there. Both the base are same.
X3.
3.
3. X equal to 3.
X equal to
Equal to
3.
3.
Equal to 3.
X
3.
equal to 3.
Yes. So 2x,
So
6.
2x equal to 6.
So x
6
equal
equal
to 3. Right.
3.
Right. Now, log base 2 5x plus 7 is equal to 5. Now, what is x?
X equal to 3.
X equal to 3. Please
3.
check. Check one
Minus
more
3.
X
time.
equal to 5. X equal
Perfect.
No,
to
X
5.
equal to 5, ma'am. 5. 5.
X
Yes,
equal to 5.
yes.
5.
X equals to 5.
2 raised
X
to
equal to
5.
5.
Yes, agreed. X equal to 5. What is your 2 raised to 5?
32.
32.
32.
Minus 7.
7.
5x is equal to 25. So your x is
X equal to 5.
Very good.
5.
Dear students, our lecture will be complete very soon. Have you able to understand this lecture?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
Our
perfect,
today's
ma'am.
ma'am.
our
Yes, ma'am.
Very
thank,
well.
thank you. Our
Yes.
today's
Yes,
lecture
ma'am.
is on
Yes, ma'am.
very basic topic, indices, surds, and logarithm. But in future or in the next lecture, we will go for the binomial theorem and the trigonometry term. Give me one more answer. Root two. Uh, root 2 raised to root 2 into root 2 is equal to 2 raised to x. Tell me what is x?
1.
X is
One,
1.
one, one, one,
One.
one.
Perfect,
One.
perfect. X is equal to
One.
1. Now, 2 raised to x minus 1 plus 2 raised to x plus 1 is equal to 2560. What is x?
Locha.
A
1.
See,
zero.
no,
No,
it is not 0.
1, 1.
Ma'am, it's 9.
1.
Ma'am, it's 9.
1. Locha. Locha.
Oh,
9.
please, if you don't know the answer, keep mum.
Ma'am, it's
Ma'am,
9.
it's 9.
No,
Ma'am,
it's
9.
not.
7.
It's not
7.
9.
1.
7.
1.
7.
See,
5 by 2.
here
1.
2 raised to x into 2 raised to minus 1
3.
plus 2 raised to x into 2, 2, 5, 6, 0.
Ma'am, 10.
Yes, exactly 10.
How?
Here, if we take 2 raised
How?
to x common, then 2 raised to minus 1 is 1 by 2 plus 2 is equal to 2560. So this is 5 by 2, right? So
Yes, ma'am.
2560, 5 by 2, that is 2 by 5.
5.
Now, by the simplification, you get 2 raised to 10. And the base is same, so x is equal to 10. Now, square root of 2 raised to n is equal to 64. What is n?
It's 12.
12.
See,
12.
here,
2
yes.
raised to 7.